In this video, we will talk about what expected value is. So I want to motivate this by looking at an example that we first looked at in the last section, which says that you bet $2 to play a game in which you roll a die. If you roll a 6, you win $5. If you roll an odd number, you win $1. And if you roll 2 or 4, you win nothing. Let X be your net earnings from playing once. So X is our random variable here. And then it asks, what is the average value of X? So we need some sort of way to measure the average value of this random variable. So let's begin by making a table in which we keep track of the outcome as well as the probability. So we actually made this table in the last section. So I'm going to make it a little bit more quickly here. So there are 3 overall outcomes. If we win $5, if we win big, I'm going to call that a big win. But remember that even if we win the $5, we did have to bet and pay $2 to play in the first place. So overall, our net earnings would have been $3 in that scenario. So this 3 is coming from the fact that it's 5 minus 2. And that happens if we roll a 6. So that the probability of that happening is 1 over 6. Alrighty, let's actually put that in a different color. Let's put that in black. So 1 over 6 for that probability. So if we win $1 by rolling an odd number, if we won $1, we overall lost money because we had to bet $2 to play. So I'm going to call that a small loss. So we could have a loss of $1. This would be coming from the fact that we won 1, but we subtract 2 because we paid $2 to play. So the probability of that happening is, well, that happens if you roll an odd number. So our probability of rolling an odd number is, well, there's 3 odd numbers out of 6 total options. So 3 over 6, which simplifies to just 1/2. Okay, and then finally, if we roll 2 or a 4, we win nothing, but we still had to pay the $2 to play. So I'm going to call this a big loss. And we'd lose $2 in that scenario. And the probability that we roll a 2 or a 4, well, 2 choices for what we want to roll, a 2 or a 4, out of 6 total possibilities. And this simplifies to 1 over 3. Okay, so let's use this table of values now to get a feel for, well, what's the average value of our net earnings? So on average, one thing that we can say is when we play 6 times, we sort of expect that we're going to follow these probabilities fairly closely. So the 1/6, on 1/6 of the time we have a big win, half of the time we have a small loss, and a third of the time we have a big loss. So we would expect that when we play 6 times, we'd expect to win big 1 time. That doesn't mean it has to happen 1 time. It might happen more than 1 time or 0 times. But on average, if we play 6 times, because the probability of this happening is 1 over 6, we'd expect to win big 1 time. So similarly, for losing small and losing big, let's write down how many times we would expect that to happen. For losing small, the probability was 3 over 6. So if we played 6 times, we'd expect to lose small 3 out of those 6 times. And for losing big, that probability was 2 over 6. So if we play 6 times, we'd expect to lose big about two times. Again, it doesn't have to be these numbers, but these are just generally kind of what we'd expect based off of these probabilities. It could deviate from this. Okay, so now let's use this to write down our average earnings. So based on these values, I'm going to set up a fraction because I have an average, and I'm playing 6 times total, so 6 is going to go on the bottom. And on the top, I need to count my total earnings. that ended up happening between winning big and losing small and losing big here. Okay, so there's one time when I win big, and when I do win big, we win, our net earnings are $3. So I'll multiply 1 by 3. And let's add that to, well, there's 3 times when we'd lose small, at least we expect. So we'll multiply 3 times how much we lose, which is $1. So I'm going to write minus 1 because we're losing money. And then there's 2 times when we lose big. So I add plus 2 times my net loss in that situation, which would be minus 2. So this is actually just the formula for average. And if we simplify this, we end up getting negative 4 on the top over 6. And I could divide the top and the bottom by 2 to get negative 2/3. And there's units here, the units of money or dollars. So it's negative 2/3 of $1, which if I wanted to put that in cents, or if I wanted to put that in decimal form, this is approximately equal to negative 0.67 if I rounded this after 2 decimal places. Okay, so well, what does this mean? Thus, on average, we lose 2/3 of $1 each time we play. So let's write this formula in another way. So I'm going to take this fraction and let's just write it in another way. So another way to write this fraction is to split it up and to say that it equals 1 times 3 over 6 plus, and then 3 times negative 1 over 6 plus 2 times negative 2 over 6. So to split it up into the sum of 3 fractions. And then we could rewrite this a little bit by putting the 3 in front. So 3 times a sixth, and add that to putting the negative 1 in front and multiplying that by 3 over 6. And then adding that to putting the negative 2 in front and multiplying that by 2 over 6. So having it in this form, one thing that we might recognize is what's happening here is we are multiplying each outcome or each value of the random variable. So my random variable could have been either I earned $3 or I lost $1 or I lost $2. Each outcome by its probability. And then sum those up. And that is going to be the formula that we give when we define the expected value. So let's give a general definition next. Alrighty, so we are ready for this definition, which says that the expected value of a random variable x with values x1, x2, comma, dot, 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 up until xk that are associated with probabilities p1, comma, p2, comma, dot, 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 up until pk. And the way I'm going to notate expected value is to write capital E, and in parentheses I'll put my random variable capital X. So the formula for expected value is going to match the type of thing that I saw here. I'm going to multiply my values, like x1, by its probability, p1, and do that for all of these. So next value is x2 times its probability, p2, and start to sum these up. So plus, plus, dot, 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 plus, until I get to the last one. The last value is xk times its probability, which is pk. And that is our formula for the expected value of a random variable. So in our example, let's just write down the expected value using our formula. So E of x for expected value. We've done it essentially already. One of the values was 3, if we had a gain of $3, times its probability, which was 1/6, plus take the next outcome, which was -1 if we lost $1, times its probability, which was 3/6, and then plus the next outcome, which was -2 if we lost $2, times its probability, which was 2/6. And we already worked out what this was. It was -4/6. And we had simplified this to negative, units were dollars, whoops, in dollars, and it was 2/3. 2/3, ooh, negative 2/3 of a dollar. So I want to end this video with an important observation. So I want to note that this doesn't mean that when we play, we will definitely lose 2/3 of a dollar. So in this example, this is actually impossible. When I play at one time, I can't lose 2/3 of a dollar. I could lose $1 or lose $2, or I could gain $3, but I can't lose 2/3 of a dollar when I just play one time. What that number means, this is just our, what we can call our long run average. If we play a bunch of times on average over the course of all of those plays, we'd expect to lose about 2/3 of a dollar each time. So, for example, on 300 plays, we expect. So I would take 300, I'm going to play 300 times, and each time on average we're going to be down, so I'm going to write minus 2/3 of a dollar. If I multiply this out, we get -200. So what that means is we would expect to lose about $200 if we were to play 300 times. So I'm really going to highlight this word expect. It doesn't mean this has to happen. It's just the expected long run average if we were to play 300 times. So in terms of our goals for this section, we've now talked about what an expected value of a random variable is. So over the next several videos, we are going to do a bunch of examples in which we compute expected values.